Everyone. My name is David Evers. I'm the Executive Director and Chief Scientist at Biodiversity Research Institute. We're based in Portland, Maine in the US, just north of Boston. And today we're going to discuss mercury monitoring in the global environment and the new initiatives that are being developed around the world. And we will actually kind of tour around the world with these new initiatives that are quite exciting. There's 5 different presenters, and it doesn't leave us a lot of time in the end for questions and answers, but I think it's important to get a feeling for what each of the presenters and their associated projects are working on around the world. Initially here, I'll just provide a little bit of an introduction, and then we'll walk through the different presenters, and at the end, there'll be some time for questions and answers, and we'll work through those as best as we can. So next slide. Just to have a little bit of context, I think it's important, just understanding where to monitor mercury in the world. It's important to use our resources in the best way possible and to really provide some context on where are the best places in the world to monitor. Models are being developed, global models that have regional and national implications. And one way of looking at those models is understand the sensitivity of the ecosystems to mercury input. And those layers can involve multiple cover types, habitat characteristics, forest integrity, soil organic carbon, water quality, climate change disturbances, and just even natural occurring mercury. That sensitivity model is very important. It's one element of 2 ways of needing to look at mercury in the environment. The other factors include the anthropogenic influence that we are having on the environment. So there's a finite amount of mercury in the world, but we as a society, global society, are releasing it in different ways, in different levels. And that's through sources like gold mining, power generation, industrial sources. So there's different source types, but also it's our ability to disturb the ecosystem through deforestation, fire management, hydrologic alterations, and sedimentation. Those are just some of the risks that we're influencing how mercury is distributed. And then when we think of the sensitivity of a system and how these inputs are manifested through the system, that's what we're thinking of as a threat. So threat equals sensitivity plus risk. So if we look at a global model, next slide, we can start to understand where are the sensitive systems around the world. A lot of these systems are related to wetland areas simply, but it is more complex than that. Next slide. And then the risk of the contamination, where are the sources of mercury? The sources of mercury through coal-fired power plants, through ASGM activities, etc. All those different sources around the world. Next map. And then we can bring that together into this sort of a threat model, that approach that we could start to think as a monitoring group of scientists and interests from a policymaking standpoint. Where are the places that we may be most concerned about mercury methylating in the environment, and that methylmercury reaching into the biota, and the biota being animals that we're interested in from a food standpoint, or from a other resource standpoint, or just the risk to those organisms. And so these red dots represent the different initiatives that we're going to step through now around the world. First will be in Italy by Nicola Peroni. Second will be in the Caribbean by Linroy Christian. Third will be in Africa, in Gabon by Jean Hervé. Fourth will be in Indonesia by Union Ismawati. And the 5th presentation will be by Claudia Vega in Peru. So why don't we go to the next slide? And I realized I went through those map slides quickly. Those will be available for you to look at later. I think I just wanted to provide that context because it's so important to step into these actual presentations and what everybody has to say. So I'd like to introduce Nicola Peroni from CNR in Italy, and Nicola is going to discuss the Global Atmospheric Network. Nicola, I hand off to you.
Thank you, Dave. Thank you for your introductory presentation. So good morning, good afternoon to everyone. My name is Nicola Pirrone. I am a research director of the CNR in Italy, and I'm leading several initiatives. But today presentation, I'd like to share, I'm sharing this presentation with our colleague Alexander Steffen from Environment and Climate Change Canada. So please, next slide. Okay, there are a number of initiatives ongoing since the last 10 years or so, even more. And now there are several initiatives ongoing now for the future to support the implementation of the Minamata Convention on Mercury and the development of a globally coordinated monitoring system for measuring mercury levels in air and the deposition samples. Now, another important goal is really to enhance and promote the coordination of existing monitoring networks and programs to ensure global comparable air monitoring data. Because of course we don't start from scratch, we are just putting together all the initiatives and programs that have been are ongoing now and that have been built in the last 10, 20 years. So the overarching goal is also to develop a knowledge hub for Mercury designed to make available monitoring data and tools for supporting decision making. As we know, we keep producing data, observational data of all kinds from all kinds of platforms, but we have to make sure that these data are available to end users. And you have to make available data also providing ad hoc designed tools to extract knowledge from this data and in order to take a decision. Then, of course, in doing this, in order to ensure global comparability of monitoring data, we have been promoting and we will keep promoting intercomparison exercises in order to make sure that the QA/QC system are comparable, and also the passive air sampler and analytical procedure that we have been adopting in existing monitoring network and labs are also comparable. So this is very key aspect. And then also to contribute to the preparation of a standard operating procedure for mercury monitoring and effectiveness evaluation. So next slide, please. So you are already familiar with this pyramid that you can find in all kinds of Minamata Convention document available online, but there are two treaty articles related to monitoring. The one is Article 22 on effectiveness evaluation, and then we have Article 19 related to research, development, and monitoring. And also we have monitoring guidance. So in the last couple of years, several colleagues have been working on this, and air is the chosen media chapter on monitoring, as we know. And then there are different tied approach, mostly air concentration, trend attribution, process understanding. So there are several actions in this in order to better understand all these factors and the indicators. So next slide, please. So just to let you know that a number of initiatives are under a big umbrella that has been developed as a part of the group on Earth observation, and specifically in this flagship global observation system for Mercury is a geoflagship. That the overarching aim is integration of existing monitoring networks measuring mercury levels in the global environment, and support of the policy process by providing a knowledge hub that allows to go from observational data to knowledge designed for end users. So you may learn more about this geoflagship at this URL that you have available now. And under this flagship, are involved most of the Mercury scientists and also several policymakers, and GEO has been observed also in the COP of the Minamata Convention. So there is a lot of effort in this direction to integrate existing knowledge, infrastructure, and capability, and a lot of capacity building. So next slide. So in the last couple of years, we've been promoting, as I said, intercomparison of exercise of a passive air sampler developed by different groups. So can you go next, please, just to show the whole slide? So we have been, intercomparing passive air sampler developed in Canada, at University of Toronto, in cooperation with Environment Canada, at IVL in Sweden, at our institute in Italy. So, and this intercomparison has been published recently. Just can you go next? In this paper, so those that are interested to learn more about intercomparison can go to this paper that is available online and also on the GeoFlagship website, so you can download this. So we need to do more of this exercise involving more people, also doing intercomparison of labs, so making sure that the analytical procedures are correctly implemented, and so on. So next slide. So this is the updated map of current passive air sampler sites available now, that so several groups worldwide are working, are managing different sites, and in order to fill geographical gaps in terms of air monitoring coverage. So as you can see, we still have quite a long way to go to cover different regions of the world that are not yet part of this effort. So and this is very important when we talk about effectiveness evaluation, because without monitoring data, it's quite hard to make any assessment. Although, you know, we use a modeling framework that have been tested, intercalibrated, and so forth. But really, the starting point for the convention is to use the monitoring data to assess whether or not a certain measure undertaken by countries or region have been effective or not, and to which extent. So this map will be made available on the GeoFlagship web portal. So next slide. So this is my planned activity. Of course, we will continue the integration of monitoring data in this GeoFlagship Knowledge Hub. So there is a continuous work. We keep receiving data from different sites and different networks. So we will keep working on this to make this available online. Promote intercomparison exercise for QA/QC system and the passive air sampler devices, including analytical procedure, aiming to prepare the standard operating procedure that will be adopted worldwide as part of the convention implementation. And then also there is a lot of research ongoing in testing new monitoring devices for monitoring mercury levels in air, deposition samples, but also topsoil and ice snow samples. That is very important to make sure that that we are able to quantify how much mercury is in the topsoil and ice snow samples. That is very important. And then one goal is also to organize, hopefully, an in-person workshop as part of the GeoFlagship activity, hopefully before the end of the year. Likely will be in the coming fall, but we will see how things will go with respect to COVID, but also now we have another big virus, even more dangerous, that is the war in Ukraine, to which goes all my support, and hopefully that this war will end soon, very soon. Too many people are suffering there. So that was my last slide. If you go next, please, just to thank everyone. So thank you so much. If you have questions, just send me email or in the chat. I will be happy to answer. Thanks.
Perfect, Nicola, thank you so much. And I think that provides a great overview of the air deposition abilities and the network that stands in place right now. So let's move to the next presentation. The next presentation is by Linroy Christian. He's with Antigua and Barbuda, and he'll provide some information about a new SIP project in the Caribbean. Linra, I hand it off to you.
Hey, good morning. Thank you, Dave, and thank you everyone for attending. Linra Christian, the Director of Analytical Services here in Antigua and the Minamata Convention focal point. And I'll be giving you an overview of our network and the formation of the Caribbean Region Mercury Monitoring Network. So if you go to the next slide. The network was contemplated due to discussions with BRI and our colleagues in the region from St. Kitts and Nevis. And this is in recognition of the fact that there are significant data gaps, as Nicola would have pointed out in his presentation, as to where we have data that can go towards the global assessment of mercury. And in that light, we would have, based on the Minamata initial assessment, saw the need to look at, from a scientific perspective, how can we improve the data generation within the region. And there we came up with the idea of the Caribbean Region Mercury Monitoring Network. And in that we would wish to improve the mercury data set in our region, and also to improve the capacity to test for mercury within the region. I mean, we have capacity within the region. It is not harnessed typically in a coordinated way, and therefore this provides us with a platform to collaborate, to expand on our research experiences, and really looking at a stepping stone to a much greater collaboration and on other spheres as well. So I think it is the formation of this network, I think, goes towards our need to build this science capacity and our understanding of how mercury affects human health and the environment. So within the network, and Antigua and Barbuda would have submitted a project to this specific international program, and key to this would be the formation of the network and to provide this mechanism for the sustainability of the network. So the government of Antigua and Barbuda would be the administrator central, and our lab will be the central lab, which would coordinate testing within the region. And hopefully from there we would expand, and we would set in place in Antigua the necessary framework for making the laboratory sustainable, because we wish for this to continue long after the SIP project has ended. Next slide, please. So what we would have done, we would have reached out to our colleagues in the region, and from that we had expressions of interest from Belize. As you can see, based on the map, we have a pretty good geographic distribution. We have St. Kitts and Nevis, Dominica, St. Lucia, Barbados, Grenada, Trinidad and Tobago, Dominica. We also have Guyana, which is on the South American shelf. And therefore, we think that involving these countries and the various matrices that we hope to monitor, that we would definitely have good coverage within the region and to improve upon the network. Next slide, please. Now, the central laboratory in Antigua would function to coordinate essentially the activities during the SIP project, which is a 2-year project, which will culminate at the end of the year, this year, 2022, with a results workshop, having done the sample collection, coordinating that by country, the handling of all logistics, the dissemination of information such as standard operating procedures. Any data that is generated, of course, would be utilized in a regional sense, and that countries can explore use of data bilaterally, because of course this is the country's data and there are some sensitivities that we have to recognize. As it relates to quality control, the issue of standards and certified reference material and coordinating the inter-laboratory comparisons would be extremely important. We have other colleagues within the network and our collaboration with the Biodiversity Research Institute who would have conducted the large majority of the MIAs within our region and also have a long history in analyzing for mercury would also assist with this. And with respect to the air, certainly Environment and Climate Change Canada. So these issues of laboratory comparison and quality, as Nicola also would have mentioned, are key to ensure that the data is of good quality. And of course, the methods using comparable methods, using different instruments, of course, to analyze whether or not we can get comparable regional data is quite important. Next slide, please. So just to give you a snapshot of what we've done so far, this is in collaboration with BRI in terms of screening hair samples in women of childbearing age. And we would have analyzed 121 hair samples. And within that, if we were to use 1 ppm as a threshold, we would see that 29% of samples would be above that. And if we use a recommended safe threshold that would have been recommended by Philippe Grandjean into some research papers that would have explored safe limits for humans, we would find that 56% of the samples were in excess of this 0.58 recommended threshold. There are some outliers that we would want to point out, 2 samples in particular, one at a maximum level of over 600 parts per million and another just about 33 parts per million. Now these we consider as outliers and likely may have been introduced to the sample through other means, and the skin lightening creams may have been one aspect, because a part of the questionnaire would have been whether or not persons utilize such creams. And in other data that we have on that, we do have some creams with excessively high levels of mercury. But it is not anticipated that the methylmercury levels seen here are as a result of dietary uptake. These levels are actually quite high. But we do have 4% of the samples that are above 3 parts per million, and this also would be considered an unhealthy level. So we do have some additional work to do to tease out what is attributable in terms of dietary uptake and other factors, and certainly opens up the scope for further research. Next slide, please. And we also have some fish monitoring data, and we found, for instance, grouper had among the highest levels of the samples that we would have screened. We also had albacore tuna, which had slightly elevated levels, red snapper, and other reef fish that typically would not have such levels, but we have found that they do have levels of concern. The sample level, of course, will be improved throughout the course of the network, but this is data that would have been obtained from samples taken in Antiguan territorial waters in Antigua and Barbuda. We do actually have some samples from Barbuda, which we would not expect initially to have such high levels, but certainly there is a need for further research. We will expand this throughout the region, of course, and have a more robust data set. Next slide, please. And so the countries that are within the network, we would have put out a call for areas of interest. With the help of Environment and Climate Change Canada, we'll be exploring passive air site deployment throughout the region. We do have an expanded fish monitoring to conduct, and we have those 4 species of initial interest, but other samples are anticipated, other species. We will have additional hair sampling. We will expand our cosmetics database because we do have in excess of 100 creams and soaps and other samples to analyze. We have a frigate bird study that Dave is very much interested in, our national bird here in Antigua and Barbuda, that we hope to gather some data on. Next slide, please. And throughout the 8 quarters, this just gives a snapshot of what we wish to do. In Q1, the coordination of the labs, which is completed. We would want to enhance analytical capacity. We would have obtained a direct mercury analyzer based on the funding that we would have received, and we have started the SOP development. Also, of course, we started collecting in Q4 of last year the biotic samples, and the lab certification is ongoing, and of course, developing the monitoring program. We hope to, within this year, develop or expand the biomonitoring plan and conduct more biomonitoring with specific areas of interest. And in Q6 to disseminate the results with a findings workshop, which would be probably later this year. So this will expand from Q6 throughout Q7. And then we develop outreach material and of course, public awareness, which would be extremely important in terms of bringing that awareness at the policy level and at the general public level to persons as to the dangers of potential dangers of mercury. And of course, we will conclude the project with monitoring and evaluation. So that, next slide, sorry. And of course, the relevance of the monitoring of within the national context, developing surveillance programs, looking at trade, because of course, testing mercury is important for export. We do have the regional capacity enhancement and technical cooperation that we see as extremely important. And at the convention level, recognizing that Articles 12 and verification of contaminated sites that we would have identified during our Minamata initial assessment, health aspects, research and development, and of course, effectiveness evaluation that we hope to contribute significant data sets through from our region and address these gaps. And of course, public awareness is extremely important to develop new policies, guidelines, and also to highlight potential health risks, as I would have previously indicated. So this concludes the presentation. Thank you. Next slide. Thank you very much, everyone.
Excellent. Thank you very much, Linroy. I apologize for the background slides. I think they leaked over from our next speaker, since we know there aren't hippos and elephants and such in the Caribbean. Next slide, Mark. So I'd like to also introduce Jean Hervé. He's with the ministry in Gabon, and Jean Hervé is going to present on a new SIP project that will be based in Gabon. Jean Hervé is going to present in French, but these slides are in English. And so Jean Hervé, I hand it over to you.
Okay, merci beaucoup. And hello, everyone. I'm the Director General of Aquatic Ecosystem of Ministry of Water and Forest of Gabon. I'm the national focal point of Minamata 2. I'm very enjoyed to be here with you. And I will speak in French. And my presentation is in English for all. So, merci beaucoup donc à tous pour ceux qui comprennent un peu français. Je vais donc vous faire l'économie de cette initiative qui vise à renforcer les capacités de monitoring et d'aménagement du mercure en Afrique centrale via un transfert de technologie et d'assistance. Je suis donc Jean-Hervé Mvébé. Cette présentation a été préparée avec mon collègue Clotaire Sika et Madame Guylaine Nkwandutu. Next. Alors, il s'agit donc effectivement du projet d'Afrique centrale de laboratoire. L'objectif étant de lancer un centre régional de surveillance de mercure en Afrique centrale en créant ce laboratoire d'analyse et pour permettre donc les analyses de mercure et les évaluations environnementales. Nous comptons fournir une plateforme et la mise en réseau pour toutes les équipes de la sous-région pour pouvoir nous aider à mieux documenter par la science la problématique de mercure dans nos pays. Au moment où je vous parle, sur les 4 pays sollicités, 3 d'entre eux ont répondu déjà favorablement à participer donc à cette initiative. Next. Alors, je suis du Gabon. Je vous fais l'économie ici de mon pays. On est un tout petit pays. Nous sommes situés en Afrique centrale, traversé par l'équateur. Nous sommes un pays essentiellement forestier, avec près de 80% du territoire couvert de forêts. Et nous représentons, on va dire, 15% des forêts du bassin du Congo. En termes d'hydrographie, nous avons un réseau hydrographique que nous partageons via 5 bassins hydrographiques avec nos voisins. Nous sommes donc un petit pays très peu peuplé. Nous sommes relativement riches et nous avons 800 km de côtes ouvertes sur l'Atlantique Est. Nous sommes un pays à climat humide et il faut savoir qu'une grande partie de la population du Gabon habite vraiment le long de la côte. Next. Alors, le laboratoire va s'adresser à 5 pays. Donc, il va être situé au Gabon et il compte aider, appuyer et structurer un réseau avec les pays de la Guinée équatoriale, le Cameroun, la République sœur du Congo et le Gabon. C'est un choix en termes d'hydrographie, c'est aussi un choix en termes de continuum naturel forestier. Next. Alors, nous avons reçu de nos amis de BIRAI cette carte qui est une carte de menace du mercure en Afrique centrale. Et comme vous pouvez le voir, nous sommes situés à des limites qui sont identifiées entre moyenne et très haute en termes de menace de mercure. Next. Et c'est donc au vu de la situation qui précède que nous avons décidé de soumettre finalement ce projet de laboratoire d'analyse sous-régionale donc à la Convention de Minamata. Les résultats attendus de ce laboratoire sont donc d'initier et de coordonner une approche intégrée pour établir un laboratoire centralisé en tant que centre d'analyse analytique pour la région d'Afrique centrale. Étant entendu qu'on veut, comme sous-objectif ou résultat, arriver à renforcer les capacités d'analyse de la sous-région, nous voulons donc recueillir des échantillons des uns et des autres et nous voulons élaborer, et nous avons commencé avec nos amis de BIRAI, donc à élaborer un plan de biosurveillance de toute la région Afrique centrale, puisque nous sommes interconnectés via les rivières, via les courants, via tout ce qui est. Nous voulons aussi diffuser toutes ces informations pour que ça serve à nos autorités à prendre de meilleures décisions par rapport à la problématique du mercure. Ça va servir aussi d'amorce, donc de starter pour pouvoir donc amener un dialogue sous-régional pour tous nos pays. Et nous voulons finalement, dans un certain nombre de forums, présenter nos résultats liminaires. Next. Alors, il est important, donc, nous n'avons pas pris cette décision au hasard. Nous avons en 2019, donc, fait une pré-enquête sur le mercure avec l'appui des universités de Cornell aux États-Unis et de Wisconsin sur les poissons du Gabon. Donc, comme vous pouvez le voir, dans nos eaux douces, nous avons des poissons de très petite taille avec des prises relativement moyennes et qui sont consommés par les populations locales. Next. Alors, l'analyse des poissons du Gabon de cette première photographie montre que de nombreux groupes d'espèces de poissons du Gabon contiennent plus de mercure que dans d'autres régions d'Afrique centrale. C'est donc un signe de ce que nous avons effectivement aussi, comme d'autres pays, cette problématique du mercure. Next. Alors, si on regarde de façon spécifique au niveau du pays en lui-même, nous avons des zones où nous avons des concentrations de mercure plus élevées que d'autres, mais vu que la mission n'a duré que 2 semaines, nous pensons que, et nous envisageons à l'aide du laboratoire qui va maintenant être en place, mieux rationaliser, mieux couvrir le pays pour pouvoir avoir une cartographie certaine en termes de taux de mercure, à la fois dans l'espace et dans le temps dans les poissons. Next. Alors, un titre sur cette enquête qui a été, je vous montre ici qu'on ne s'est pas arrêté qu'aux poissons. Nous avons travaillé aussi sur les plantes, sur l'air, sur tout ce qui est sol, sur les sédiments, et aussi un de nos collègues venus d'Amérique qui était ici a mangé du poisson, et on voit un tout petit peu comment a évolué le taux de mercure dans ses cheveux au cours de son séjour au niveau du Gabon. Donc, le faible niveau de mercure dans les échantillons abiotiques suggère une sensibilité élevée de l'écosystème, des écosystèmes dulsacicoles du Gabon à la méthylation, et c'est ce qui s'exprime en fait dans les poissons, puisque ça intègre le réseau trophique et ça se retrouve finalement vers ce qu'on va appeler les organismes supérieurs de ces réseaux-là. Next. Alors, par rapport donc aux conclusions de cette enquête qui vous sont données ici, beaucoup de poissons au Gabon sont largement et régulièrement contaminés en mercure. Les écosystèmes du Gabon semblent présenter une sensibilité à tout nouvel apport de mercure provenant des activités humaines. Donc, nous pensons aussi que ça nous suggère que des efforts vraiment importants sont à mettre sur la surveillance et l'évaluation de l'environnement pour protéger donc la santé humaine et identifier les changements qui peuvent être induits par les activités liées à leur paillage et à d'autres activités par rapport au plan national d'action de la Convention Mercure. Next. Alors, dans nos prochaines étapes, nous entendons, avec l'appui de la plateforme que nous sommes en train d'installer de ce laboratoire, donc recueillir plus d'échantillons à la fois sur l'environnement et aussi chez les êtres humains, parce qu'au niveau du Gabon, il faut l'accord du Conseil d'éthique pour entreprendre ce genre de travaux. Nous travaillons donc sur cette problématique-là. Nous voulons donc faire le lien aussi entre le niveau de mercure dans les poissons et les niveaux de menace, identifier les niveaux de menace, établir les cartes de sensibilité pour comprendre les risques pour les personnes qui vivent à côté finalement de ces ressources halieutiques. Et nous voulons aussi surtout identifier, parce que ce n'est pas très clair, d'où viennent ou quelles sont les sources de mercure qu'on retrouve finalement dans les poissons du Gabon. Next. Donc, j'ai essayé de faire court pour tenir dans les temps. Si vous avez des questions, je suis tout à fait ouvert à vous répondre maintenant et beaucoup plus tard. Donc, mon mail est dans la fiche qui a été envoyée pour ce side event. Je vous remercie beaucoup de votre attention et encore mes excuses pour le français pour ceux qui ne le comprennent pas.
Great. Thank you very much, John Hervé. the fish mercury concentrations that you presented are surprisingly high. So it'll be interesting with this SIP project on how we can move forward. And I think we can all see with the hard work by Dr. Christian in the Caribbean region, how a lot of that, how a lot of the approaches are transferable to other regions, such as Central Africa. So I really do look forward to Jean-Nové's hard work and his networking with his colleagues. And perhaps there's even next steps that we can strive for around the world with this sort of approach. With that, I'd like to introduce Yuyun Asmawati to discuss mercury monitoring initiatives in Indonesia. Yuyun, I hand it off to you.
Yeah, thank you, Dave. Thank you, everyone. Good evening, good afternoon, good morning. Thank you for the opportunity to share in this side event. And thanks to all the BRI and Nexus 3 team for pulling this out together. Could you please, next slide, Mark? Yeah, so the monitoring of mercury has been discussed in, has been an ongoing discussions under the COP4, and also will be continue discussed in more details, especially about the environmental matrices and also the biomarkers that will be collected as part of the global monitoring. And in Indonesia, we are focusing on the work in the selected SGM sites. We look at the human dietary expert and the source of mercury from SGM activities, and then the rare high trophic level of species that are affected. And then because many of the SGM hotspots also located in the biodiversity sensitive areas. And then we also at the economic and commercial interest of the impact and the activities and its impact of mercury. Next, please. Give you a bit of a background. The policy framework on mercury management in Indonesia has been stipulated under the Presidential Decree number 21, issued in year 2019, 2 years after Indonesia ratified the Minamata Convention. And in this National Action Plan to reduce and eliminate mercury, the Indonesian government targeted to phase out the mercury devices, the medical devices containing mercury by 2020. Why? Because we had started it earlier in 2016. But the implementation of this withdrawal of medical devices are still ongoing until now, due to lack of storage facility. And for the SGM sector, the National Action Plan stipulated that by 2025, mercury will be eliminated in 100% in all SGM hotspots of Indonesia, which is in 3 years' time. And several projects now already demonstrated that mercury can be replaced with something else, cyanide and other methods. But this is need to have a more push because the mercury use in 180 hotspots need to be monitored closely. And then in the energy sector, the Indonesian government has the target to eliminate or to reduce mercury by 30%, 33% by 2030. This is mainly from the coal-fired power plant. And then lastly, from the manufacturing sector, especially lamps and batteries, will be reduced 50% by 2030. So to give you that, with that background, we will understand how it works for the monitoring in Indonesia, mercury monitoring in Indonesia. Next, please. Yeah, in 2018, we have identified about 190 regencies in Indonesia out of 514 regencies, SGM practices. And with this number, the number of miners that registered in the association of miners, small-scale miners, are more than 1,200,000 people. That's the miners who registered already. And we have about probably around 10 million population at risk in these areas, spread out all over Indonesia, that risking their lives exposed to mercury from SGM. And next, please. Oh, the 15 national parks has been identified. And this map shows the potential contaminated sites in all over Indonesia. And we identified based on colors. The red one is the places or sites that have been more than 10 years have SGM activities, and then mildly polluted between 5 to 10 years activities, and some areas are still active. And the gray is for where the SGM activities are less than 5 years, and most hotspots are still active in the gray areas. From the data collected from the Ministry of Energy and Mineral Resources, the number of consumption of mercury by miners are between 1,000 until 3,000 tons a year. Next, please. So to monitor the impact of mercury to the human health and the communities, especially in the impacted areas, collecting hair is the easiest way. It's a non-invasive method, and the biomarkers of hair has been acknowledged as a good way to trace mercury in our body. And representing the last 3 months of consumption of mercury. And then urine also used as the biomarkers that can be applicable in many places. Next, please. Yeah, so this is the chart showing and comparing Indonesian mercury inventory, comparing Indonesian emissions versus the global emissions. Globally, and the emissions of mercury came from SGM is only about 34% of the total global emissions, or below 200 tons of kilograms of 200,000 tons of mercury per year. But in Indonesia, the emissions from SGM is more than 50% of the national emissions, and it's about 150 tons a year. So comparing this percentage of emissions between the global and Indonesia, it's quite shocking for me as an Indonesian, because the sector is really showing that they are the source of mercury, very significant source. Next, please. So from the various studies that we collected and also from the samples collected last year with the support from the World Bank in 5 hotspots, we identified that all of the abiotic parameters are already above the standards, and also plants and fish. In general, the fish, the mercury concentrations in fish is still below the threshold. However, this is due to the small sample size. So there is a need to take more samples to have a better representative of the values. And in human biomarkers, mercury in blood, hair, and urine already above the safe level. It's so sad to see that this kind of charts also has been presented and seen in other regions that previously presented by colleagues from Barbuda and Antigua and also from Africa. Next, please. Large portions of Indonesian society, both directly and indirectly related to SGM activities, are contaminated or exposed above the safe threshold. And for the biomarkers of SGM for communities who directly exposed, meaning that those who live in SGM hotspots, more than 70% have concentrations above the safe level. So this is to show that whether you are affected directly or indirectly, because the mercury already used in Indonesia, especially in SGM hotspots since the 80s, this shows the high risk of exposures in the long term. Next, please. And this is also shows the comparison or the positions of Indonesia compared to other regions. Unfortunately, we are ranked the second globally, which also almost similar to Oceania, because Indonesia is an archipelago, and eating fish is in many places in Indonesia is the main diet. So it's not surprising. Next, please. Yeah, and also some species of fish are more at risk of contamination, as explained also by other colleagues from the Caribbean. So, but still, we need to see further and collect more samples to see and what will be the best advisories given to the community who consume a particular fish. Next, please. And for monitoring, we have developed in Indonesia a program under our organization called CHIME. CHIME is an abbreviation of Children's Health Intervention in Mercury Polluted Environment. We developed this program because we have concern about the children who live in the SGM hotspots. And the program allow us to play with the children to assess their situations using the rapid participatory assessment toolkits that we developed, including the mapping and then FGDs, make them talk in a group and then ask them specific questions. We use also snake and ladder game to check whether the students or the children understood what we are asking them. And then also there is a medical interventions for children who needs help, and also capacity building for teachers, for health workers and parents, how to take care of their children. And then lastly is the rehabilitation in various interventions, cleaning up the soil and the water wells and so on. Next, please. Yeah, so the next step is biomonitoring. We have the project supported by the US Department of State that this is the continuation of our previous project that will allow us to have more samples collected to have a better understanding about how far the mercury already affecting Indonesia's significant places. And the need to build from the existing World Bank data set, working with local university network, and also to build the mercury laboratory capacity to help us the long-term structures of monitoring. And with the support from Terre des Hommes, Germany, we also developed a campaign or awareness raising about the ecological child rights, and also the awareness to for the communities and also the children for their health monitoring using the toolkits that we developed within the CHIME program. Next, please. I think that's all from us, from me. Thank you for your attention. You can find the information in these links. Back to you, Dave. Thank you.
Thank you very much, Union. It's very important information from one of the major hotspots for mercury in the world. Our last presenter is Claudia Vega from Cincia, and she'll be presenting about her efforts, mercury monitoring in Peru. And we're a little bit short of time here, so if anybody has any questions, please put them in the chat. And then we may go a few minutes over, so hopefully you can hold on and listen to Claudia's important presentation. Claudia, I hand it off to you.
Dave, thank you for the invitation to this important space, and good afternoon and good morning, everybody. So I'm Claudia Vega. I'm the coordinator of the Mercury program in Cincia. Cincia is an alliance with Wake Forest University in USA. And what I want to do is I want to tell you the story of what the work that we have developed the last 4 years in Madre de Dios. Next slide, please. So Madre de Dios is the south part is located in the south part of the Peruvian Amazon, and is one of the biodiversity hotspots in the world. Is named by the Peruvian government as the capital of the biodiversity. Next, please. The main economic activity in this region is ASGM. So that's one of the motivation why Cincia was created here. And one of the Mercury program goals is to understand the dynamic of mercury in this region, and is what we have been developed the last 4 years, and also in the last months we have been developing another initiative with the Minamata Secretariat to develop a technical background document that gives certain recommendations on how to monitor ASGM monitor mercury in SGM sites and around them. So I want to tell you, I want to guide you through the recommendation we are pointed out in this document. And the first recommendation, the next slide, please, is to gather information about the SGM sites. And next, please. The information that we have of SGM in the Peruvian Amazon is that it has been going up the last 30 years. And as you can see in the graphic, the last 10 years, the activity has grown rapidly. Even though in 2011, after 2011, the price of gold dropped, you can see the deforested area increased because it's the same year the interoceanic highway was implemented. So even though the gold price dropped, we can see a large amount of area deforested. Next slide, please. And the picture in the Madre de Dios, it looks a little bit like this. So around 115,000 hectares is deforested by the SGM activity. Next slide. Next, please. And if you want to think about that, this area is like 160 soccer fields. It's a big amount of area, and it's distributed, as you can see in this map, all over the department of Madre de Dios. So you can see the interoceanic highway. There are areas impacted by SGM, and you can see in this map that how the SGM activity has been developed in the last 30 years. Next slide, please. So we have this area that are deforested due to ASGM, but this deforested area is not just loss of vegetation. What we saw is like around 25% or more of this area is new wetlands. So this deforested area, some part is covered by water. Next slide, please. So it looks a little bit like this. We have the deforested area with mining ponds formation. Next, please. So in order to define the goals of the monitoring program, this information is very important. Next, please. So we know that mercury is being emitted in Madre de Dios is around 182 tons of mercury per year has been estimated to be emitted in Madre de Dios. Next, please. And it's going to this type of ecosystem, right? Next, please. And can you press next 4 times here because it's an interactive? So thank you. So what we know about mercury, it can travel and it can redeposit in water bodies. Next, please. 4 times, please. Thank you. So what happened in water bodies? It's mercury methylate, and that's the way the mercury goes into the food chains. Next, please. Next, and next. So in this methylation, it's this methylation, the mining ponds and lake presented methylation rate 5 or 7 times greater than rivers. So these water bodies are important to study. Next, please. So we know that these water bodies, these mining ponds, are not dead, are alive. They have a big, large biodiversity. And one of the studies that we performed to study the biodiversity show like a lot of species that are growing, that are colonizing this mining pond. Next, please. So this gives us information to what we want to do next. And what we did is this methylation occurs, as I said before, in natural lakes and also in mining ponds, right? So as you can see in this map, there's a yellow area, is where the ASTM activity takes place. And we selected some site collection in this area that were mining pond and oxbow lakes. And to understand how ASTM affect these mercury levels, we also decided that we needed control sites. And as you can see, there are certain sampling sites upriver the ASTM areas. Next, please. So we have control site and we have a affected area, right? So once we defined that, we need stakeholder on board. And for us, the main stakeholder in Madre de Dios are the miners. So how we get in contact with that? We have a reforestation program that is developing methodologies to reforest the deforested areas. And they start to develop this technology with the miners. And we explain to them how important it is to monitor mercury in this mining concession. So that's how we get some miners on board, and we can get into this area, these mining site areas. And also we have to identify how to secure the resources to develop this program, this monitoring program. Next, please. And for that, the local partnership with research institutes is very important. So in 2017, we implemented the first mercury lab in the Peruvian Amazon with one of the research institutes of the Peruvian Amazon. Yep. And now we have the local capacity to monitor mercury in different samples. Next, please. And with that, we designed and conducted field samples collection. Next, please. And the objective of this sample collection was to monitor what is going on in this aquatic ecosystem that I showed you. And for that, we collected sediment and fish. Next, please. And the result that we observed is if we just base it our conclusion in sediment, we can see that in 2017 and 2018, we collected different samples, and we can see that the levels of mercury in mining ponds or control sites didn't present any difference with the mining ponds. There was not a significant difference between the level of mercury of mining ponds and control site. Next, please. But when we see to the mercury levels in fish, we observe that there's a significant difference between the mercury levels in fish from mining pond with the fish from control site. And as you can see the biomagnification. This significant difference is consistent in all the trophic levels. And of course, the carnivore fish present higher levels and represent more risk to human population or also wildlife. Next, please. So we know, observing to the data, that there's the ASTM affects the mercury levels in aquatic ecosystem. And we wanted to know what happened with the terrestrial ecosystem around these mining ponds. So in 2019, we conducted a project to examine how the mercury levels were in birds and bats, bird feather and bat feather, and bat fur. Next, please. And what we observed that the levels of mercury in birds from mining ponds were really high. The piscivorous birds presented really high levels. And even though we didn't catch any piscivorous fish in the control site, next please. When we compare the mercury in birds from control sites and mining pond, we see a significant difference between the mercury levels, and mining pond have significant higher levels. Next, please. And we see the same behavior in bat fur. As you can see in the graphic, the mercury levels in bat fur in vertebrates are very high, and is one of the highest mercury register in bats. And next, please. When we compare the feeding habits that were collected in both in mining ponds and control sites, we can see again a significant difference between the levels of mercury in ASGM affected sites. Next, please. So we know the mercury is affecting the aquatic ecosystem and the terrestrial ecosystem around the ASGM area. So also, as the first presenter mentioned, we also needed to understand how the mercury is traveling. And in collaboration with the University of Toronto, we deployed some passive air sampler, next please, in urban areas, next please. And this is Puerto Maldonado. We deployed a passive air sample. This was part of a PhD thesis from a student from the University of Toronto, Natalie Sporner. And we observed that there are hotspots of mercury in air in areas around the local market where the gold shops are located. Next, please. And we see this pattern in a bigger area. We deployed some passive air samplers in the interoceanic highway. Next, please. And as you can see, the mercury levels in air are concentrated in the urban area. You can see Puerto Maldonado, Laberinto, La Pampa, and Masuco. The last three cities are basically mining cities. And you can see the mercury levels going high when you approximate these areas. Next, please. So with that, we know that mercury is emitting through the amalgamation process. And one of our collaborators, she from the University of Duke, she just published this article that tells us the story that how the Amazon forest capture high levels of atmospheric mercury pollution from artisanal gold mining. Next, please. So what Gerson is basically reporting is like what is how canopy from forest can capture mercury that is in the air, and when it captures the mercury that is in the air, it integrates this mercury into the soil. So it does it through fall and later fall. So that's the mechanism that the mercury that is emitted in the air incorporated to the soils. Next, please. And we saw this behavior also in some of the mining concessions that we sampled. As you can see here, the deforested area are arid, where the tailing where tailing from the mining activity is deposited, and it's like a sandy substrate. And we collected some samples there, also collected samples in forested area. Next, please. And what we saw is what Gerson was reporting, like soil from forested area has higher levels of mercury. So having forests, it helps us to clean up the air, but concentrate the mercury in the soils. And also that it's better that the mercury is in the soils and not in the aquatic ecosystem, but also this has some impact for the terrestrial ecosystem, as we already saw. Next, please. So the next step, the last step, but not the least one, is I think is one of the more important, what we do with all the results that we produce. How do we communicate to the stakeholders? So next, please. So we published some scientific paper, but we know that stakeholders, they don't read the scientific paper, so we produced this research brief. The research brief have the main results from our research, and is written in an easy way to understand. And we handle this to the policymaker, with the minor, with student, and also we do some conference and with some event to disseminate this information. We also work with the Ministry of Environment, and all this information is published in a way that people that are not scientists can understand it. Next, please. And as the last presenter said, more important part is to transmit this to the new generation. So we also work with the school. We create this material to present the data that we are observing. And in this material, we transmit where are the mercury levels, the highest mercury level in fish, and we give some fish consumption advisory, which are the fish that have lower levels to consume. Next, please. And which are the fish that have the higher levels. So we produce material like cartoons and video. And the videos also, we find out that it was the best way to transmit this to indigenous population, since they base their diet in fish consumption. It was very important to transmit all this information to them. And we translate these videos into indigenous dialect so they can understand it, and also produce this cartoon or this big poster. So when there's no electricity in the communities, we can transmit all the information in an easy way to understand. Next, please. So that's what I wanted to transmit to you, the experience that we had the last 4 years. And right now, we know that the ASTM activity is also going to the north part of Peru. And we want to use this information that we produce in Madre de Dios to the north part of Peru, and also seeking for other partners to continue this work in the north part and try to raise awareness about the ASTM impacts that causing in the Amazon. Thank you very much. And well, I'm open for any questions. Thank you, Dave.
Thank you, Claudia. Very important work in a very important hotspot of mercury in the world. I wish we did have time for questions. I know we're over time. I really appreciate everybody sitting in still for continuing to listen to this session on mercury monitoring. If you are looking for more information, there's more information here about the ecosystem sensitivity mapping I mentioned earlier in the beginning of the session. There's more information on the Caribbean Region Mercury Monitoring Network that Dr. Christian is overseeing. And there's also more information on mercury monitoring in Indonesia that I showcase here. I should mention that Claudia and Cynthia also have very good information and communication pieces on mercury monitoring efforts in Peru. And then I know Jean Hervé is working hard to develop his monitoring network in Central Africa, and there'll be communications from his country as well. So I'd like to just wrap up with this session on mercury monitoring. And again, thank you to everyone for sitting in for this time period. And I don't know if, Manuel, I'll hand it off to you. And I'd like to also thank again all the presenters that put in their hard work and time here.
Thank you.
Manuel? Yes,
Thank you,
everyone. And Manuel, do I hand it off to you? Thank you.
Thanks.
Yes, thank you, Manuel.
Stay safe. Bye-bye.
Okay, very good. Thank you, everyone.
Thank you.